All right, everyone. Welcome to our webinar. My name is Jen Fuentes, and besides being a unicorn, I am one of the solution advisors here at CDA. Joining me on the demos, because I really don't want to scare y'all away, we have Anthony DiDonato and Trevor Prokop. We would like to thank you all for taking the time to attend. Today, we're going to take a deep dive into DevSecOps. We put a lot of time into developing this presentation and demo, so we really hope you get something useful out of your time spent. Before we get started, I do want to point out that we will be putting reference links in the chat throughout the presentation. Okay, fasten your seatbelts because this is going to be a fast and fun ride. Let's go ahead and dive right in. Software is everywhere. The more software we have, the more risk exists. Companies have adopted the agile development approach at a rapid rate, and many times security is an afterthought. So we want to show you how to shift security to the left and why. We're going to focus on automation and integration of security into your CI/CD pipelines. Sorry guys, that was on the wrong slide. Okay, cool. So let's quickly go over the agenda. We're going to have a high-level discussion of what DevOps and DevSecOps is. We will review some of the developer add-ons, secrets management, and some best practices, linting and code inspection, some dependency mapping, container scanning, vulnerability assessment, quality gates, and integrated issue tracking with Jira. This demonstration will leverage SaaS-based services as opposed to on-prem CI/CD tools, which is pretty cool stuff, right? I don't expect y'all to answer all at once. So at the end of our presentation, we will have an open Q&A session where you'll have the opportunity to ask our resources any questions you may have. But should you have questions throughout the presentation, don't hesitate to put it in the chat. Okay, now let's start off by talking crap. Everyone that knows me knows this is one of my favorite things to do. And thanks to Anthony for creating this acronym. You're probably thinking, what the heck is this crap and what kind of acronym is that? Well, it stands for Common Resource Allocation Problem, which is caused by gaps in your security team available time, skills, and in some cases, the people. This is how technical debt is accumulated, and who the heck likes any kind of debt, right? Now let's dive into DevOps, which in my opinion is one of the coolest things in technology nowadays. Effectively, this is infrastructure as code, where we automate all stages of building, staging, testing, and deploying code, and in some cases, configuring changes. DevOps is typically associated with the terms CI/CD, continuous integration, continuous deployment, or using the agile methodology. Now raise your hand if you love automation. I should see everyone's hands going up since automation, in my opinion, makes the work life easier. Plus, I just wanted to see who was paying attention so far. Okay, now what is DevSecOps? As I just briefly discussed, DevOps is infrastructure as code, where we combine software development and IT operations. The focus is often on speed, quality, and rapid delivery, not security, which is not good. Security is often an afterthought that requires more work for everyone, developers included, and impacts the overall total cost of ownership. Shifting security to the left integrates security into the DevOps CI/CD pipeline and reduces time and cost. Simply put, DevSecOps is an augmentation of DevOps to allow for security practices to be integrated into the DevOps approach. Now think of it this way. We're adding and automating security controls and testing to the DevOps process. Let's talk about the developers, the source of innovation for businesses and their customers. Developers are typically driven by an agile team approach. This comprises workflow to address issues related to bugs, features, or enhancements. The issues are tracked and addressed in an integrated development environment, also known as IDE. Multiple developers write or modify code using a source code management platform. Think of it as they're checking in and checking out the code. This typically entails creating branches or copies of code for modifications using a push-pull approach, with the end result being a merge of the changes by peer review and other quality controls. After the developer adds their code or changes to the environment, it typically kicks off a build. That build is automated and managed by the CI/CD pipeline. The basic approach is this: clone the merge project, build it, deploy it to a staging environment, do a little bit of testing, and then deploy to production. So how and where do we integrate the security? We start off by checking for secrets. We do some static code analysis, also known as SAST. We identify the dependencies, and then maybe we scan the Docker or Kubernetes containers. These scans are going to produce reports or artifacts for review by security professionals and developers. This pinpoints the issues for review and remediation. We can use the output of these scans to introduce quality gates. Basically, do we allow the insecure code to proceed or stop? If this occurs, we should create an issue and track it through the developer workflow. Additionally, further code analysis can be performed using the Dynamic Application Security Testing, also known as DAST, or Interactive Application Security Testing, IAST, typically referred to as pen testing or web app security testing. This also produces different artifacts used for quality gates or issue tracking. Throughout this webinar, you will hear a lot of acronyms because we just don't have enough, right? You're also going to hear different product names, tool references, and other foreign terminology. But here are some important acronyms you should understand when discussing DevSecOps. SAST, Static Application Security Testing, which is used to secure software by reviewing the source code of the software to identify the sources of vulnerabilities. Although the process of statically analyzing the source code has existed as long as computers have, this technique spread to security in the late 90s, and the first public discussion of SQL injection in 1998, when web applications integrated new technologies like JavaScript and Flash. Unlike dynamic application security testing tools for black box testing of application functionality, SAST tools focus on the code content of the application, white box testing. The SAST tool scans the source code of applications and its components to identify potential security vulnerabilities in the software and architecture. Static analysis tools can detect an estimated 50% of existing security vulnerabilities. In the software development lifecycle, SAST is performed early in the development process and at code level, and also when all pieces of code and components are put together in a consistent testing environment. SAST is also used for software quality assurance, even if the many resulting false positives impede its adoption by developers. DAST, Dynamic Application Security Testing Tool, is a program which communicates with the web application through the web front end in order to identify potential security vulnerabilities in web application and architectural weaknesses, which performs a black box test. Unlike static application security testing tools, DAST tools do not have access to the source code and therefore detect vulnerabilities by actually performing the attack. Last but not least, IAST, Interactive Application Security Testing, which, fortunately for you, we're not going to dig into this one today. If we approach DevOps security and start with the developers, we have a lot of options. Most integrated development environments have security-related add-ons, and we will demonstrate some of those today. Focusing mostly on CVE, Common Vulnerabilities and Exposure System, which provides a reference method for publicly known information security vulnerabilities and exposures. CWE, Common Weakness Enumeration, which is a category system for software weaknesses and vulnerabilities. It is sustained by a community project with the goals of understanding flaws in software and creating automated tools that can be used to identify, fix, and prevent those flaws, as well as CVSS, Common Vulnerability Scoring System, which is a framework for communicating the characteristics and severity of software vulnerabilities and overall security best practices. Many times the focus is on the OWASP Top 10, SANS Top 25, National Vulnerability Database, and MITRE. But we'll also talk about and demonstrate vulnerability scanning, container scanning, source code management and Git integration, dependency mapping, and secrets management. Now the fun part, where Anthony will briefly discuss his lab environment and lead into the demos.
Yeah, thanks, Jen. Thanks for the background and providing the introduction. Really appreciate it. I'm going to switch over to my screen. So my name's Anthony DiDonato. I've been a consultant since 1995, probably longer than some of the people on this call have actually been alive, which is scary and fun. I'm a principal architect for Critical Design Associates. I've run the gamut of technology, programming. I've experience in DoD and commercial, focused particularly on the Fortune 500. So let's do this. From a presentation and demo perspective, I'm going to start off with development. And with development, we're going to talk about the tools that your developers are using, going through GitLab, using GitLab as a source code management platform, as well as a CI/CD pipeline. Obviously, we'll be using a lot of Docker. And then we have some security tools integrated for a demonstration. Particularly, we're using Sneak for container scanning, as well as dependency mapping. Git Guardian, which I will briefly show, but I will not demonstrate. Sonar Cloud, and Jira. From a code or integrated development environment perspective, I'll be using WebStorm because my demonstration focuses on a Node.js application, and naturally GitLab will be a primary component. Through GitLab and the development process, we'll deploy 3 environments: a staging, test, and production environment. We'll talk about the details in another slide on what exactly is going on in each one of those pipeline builds. We'll demonstrate the initial build, and then we'll add security to that build. In particular, we'll add secrets detection, static application security testing, dependency scanning, license scanning, and last but not least, dynamic application security testing. All through templates provided by GitHub, completely open source, so if you needed to modify them, you could. Had some content presented or ready for presentation earlier, but it would have pushed us over the hour where we get into regex and customizing some of these tools for semantic scanning or even secret scanning. And then when I'm finished with my demos, there'll be a bonus demo where we're going to talk about the open source security foundation CVE Benchmark tool, which is pretty awesome. Trevor and I saw that at Black Hat. We'll talk more about it later, but it allows you to test your SAST tools for effectiveness. And the beauty of it is free, it's open source, and you can contribute if you like. So from a developer add-ons perspective, and my WebStorm IDE, which is used predominantly for JavaScript and Node.js based applications or TypeScripting. I'll show you Sneak, the Node.js node security add-on, as well as SonarLint integrated with Sonar Cloud. So let's get into that. So what I have here is my GitHub repository cloned to my local developer workstation. In a CI/CD pipeline or even an agile team, you're going to have multiple developers working on code simultaneously, checking in, checking out branches, working on issues, bugs, enhancements. What we recommend is starting with the developers so that they see the code vulnerabilities moving forward. How that's done with most development environments, there are tools that can be added to their IDE. In particular, with plugins, if you look at what I have installed, I have Code Scan, Dependency Analytics, Node Security, Sneak, SonarLint. Not all of these are free, but they do save you time and money in the long run and slow down the development process slightly because code is scanned actively. I can show you some other cool stuff as well with machine learning. But what we have is our development environment, our source code here on the left, I'm sorry, on the right, our repository on the left, and then we have the add-ons, which are typically shown here in the toolbar. Because I have Node.js or the Node security plugin, it shows me all kinds of code quality issues as well as security issues. So for example, it would tell me in particular where I have a problem and what I can do to fix that. Then I have another plugin here which is Sneak, and Sneak does an active scan or a scheduled scan. I can show the high, the medium, and the low components. Like for example, hard-coded secrets and where they're stored, or code injection vulnerabilities. Not only does it point out that I have code injection challenges, but it also gives me recommendations and examples on how to fix that and other teams that have fixed it. So I can scroll through as a developer and take a look. I can also look at the common weakness and the number associated. So for example, in this one, it tells me get rid of this commented code. And over here, I'm using eval, which will take input from the user and allow the user to control through input, code injection. And then last but not least, I have Sonar Lint. And that goes through the process of scanning my code, but also reporting back to a central repository so that I, as maybe a development manager, have the ability to look at all the code across the board, see where those components are weakest, whether from a code quality perspective or security perspective. I can look at the blockers or the vulnerabilities that are going to shut down my pipeline or cause a quality gate to get triggered. So you can see here that I have different issues. I have references to where they're documented from OWASP top 10, SANS top 25, or even common weakness exposure enumeration. So the developer has the opportunity, or the development manager or the agile or scrum master have the ability to go in and take a look at the code and look at the issues and see why it's an issue. So they can rapidly communicate risk to stakeholders, line of business owners, and things like that, while the developers have reference points to go back and change that code. All right. So that's a brief introduction on integrated development environment and tooling. We also have secrets management controlled on the back end to protect developers from uploading secrets. And I'll show you some of those tools as well. So before we get started, the pipeline is going to take a few minutes to run. What I'm going to do is kick off that pipeline, and then we're going to talk about what that pipeline is doing. So imagine the developer has already made their changes, committed their code. It's pushed up to the SCM or source code management platform, and now we're going to trigger a build. In this case, we're going to start out with a blank pipeline, and I have it prepared. So we have a basic pipeline that is going to build our production, staging, and test environments. And I'll talk about what that is and where that's all hosted. Everything is cloud-based in this environment. Every demo is live. So may the demo gods be with us. What we have here is pretty simple. 3 stages: staging, testing, production. I have staging jobs. I'm using the Ruby latest image from the GitHub Docker repository. GitLab Docker repository. I have a test stage, same environment. The only variation here is we have our staging environment variable, our test environment variable, and my production environment variable. So this is a pretty simple pipeline. All we're going to do is kick this off so that we can let that run. You'll see here there are 3 environments, and when it's completed, we'll be able to go back and look at the results. I'm not going to make you watch that because it takes about 3 minutes. So we'll commit that change. That will kick off the pipeline. Once that pipeline starts, we'll talk about what's going on in there. Okay, so staging is underway. Pulling down our Docker container. Let's go back. So what's going on in this pipeline? As I mentioned, if we watch, you see a lot of text flying by. You see a lot of automation occurring, which is in fact what is occurring. I'm using the GitLab CI/CD pipeline with Docker containers. I'm deploying a staging, test, and production environment. I'm using Heroku to host the application, mainly because it's easy and it's relatively inexpensive. I could host that anywhere, AWS, Azure, it's all relative, Google. I have a Node.js application, which is effectively JavaScript. That is the application platform. So I have the Node.js add-on in my Heroku application hosting settings. I have a MongoDB Atlas database hosted on MongoDB. So 3 different platforms all integrated together. And what I'm pushing out from a code perspective is the OWASP Node Goat, which is a vulnerable Node.js application. Let's go take a look at our results, see if that's finished. If not, we'll move into security. We are running and we're still in staging. What that's going to produce when we're finished is this. And I'll give you a quick run through of what we have here. I have my Heroku platform. I have my staging, testing, and my production OWASP node goat applications. I have my MongoDB cluster where I have all my collections. We'll be producing this OWASP node goat application, which is a known vulnerable application. This is the production instance, so it hasn't triggered yet. You've already seen the Sonar lint. We have Sneak integrated and also Jira. And if you're interested in the OWASP node goat project, you can take a look at that as well. So pipeline, let's see where we're at. We will move on while that goes. Because it's a shared runners, it's going to take a few minutes. So deploying the pipeline. When we're deploying this pipeline and we're talking about security, we're going to be adding a lot of different components. So while that pipeline is running, I'm going to go back to the editor and we're going to add some security components. Those security components are pretty simple and very easy to integrate in GitLab. If you don't have GitLab Ultimate, you don't have access to these templates, again, it is open source and you can add whatever you need to your environment. And I will show you a demo later on secret scanning where we're not using a template, we're just using publicly available tools. So here's our pipeline. We know that it's running. We know that we have our 3 environments. Sorry for the mouse over. We have our staging, testing, production. All 3 of those are not going to change. We're going to go to the bottom of this pipeline and just add a couple of pieces. And if you notice, I'm using DPO, which is Travis' tool, but I'll talk about that later if you have questions. Well, in order for this to be effective, I'm going to have to add some variables to the environment. In particular, I'm adding the OWASP node goat URL for my Heroku app, because when I run my dynamic application security testing, I'm going to do that against my production environment, mainly because it's a passive scan. If I was doing an active scan, I would more than likely target staging so that I don't knock over production. How we integrate security is pretty simple. If you look at this pipeline, there's only 46 lines. However, because I'm using templates, which you see here, those templates actually expand this pipeline. And if we were to visualize it, you won't see that until I actually click on there. When we look at the view the merged YAML, which right now you cannot see, we will go through and take a look at this. You'll see there's no DAST job. So what I need to do is add a stage here. We'll just call that DAST. Now I have a valid YAML file or markup or a pipeline file. I have my templates. The first one I added was secrets detection, followed by static application security testing, followed by dependency scanning, which we'll talk about. I have some cool images for you there. License scanning for compliance, as well as the dynamic application security testing template. We'll go through what each one of these is and what they're actually doing in a second. So I'm going to commit this because this will also take a few minutes to run, and then we'll come back and check that pipeline after production, the other pipeline is completed. So if we look at our base build, staging, testing, production, it is still running. Staging is complete, and we're into the testing environment. So we'll let that keep running while we talk about the technology and what's occurring in the background. So the first thing I added was secrets, and we're scanning for secrets. When we talk about secrets, what are they? They are effectively stored credentials. They could be as simple as a username and password in a JSON file or an XML file. They could be a bearer token for a JSON web token. It could be a private key that's required for some form of authentication or enhanced automation, or even an API key. When you're dealing with cloud-based services or even on-premise based services, you're typically using API keys to control authentication between applications and allow that integration to occur. Often developers will hard code or store credentials in obfuscated locations, and they will push out your credentials to the public if you're live. We'll talk about some examples of where that's burned people in the past. Some of you actually may have been burned by the same problem. And then what is the solution? We know what the problem is. The solution is to scan for secrets. We're using the secrets detection template. And in this instance, which I'll demonstrate in a minute, I've created some basic regex search strings to find items of interest. In particular, I'm looking for JSON web tokens or just generic passwords, and we'll talk about the regexes associated with regular expressions. So the solution is scan, customize your templates to look for things that you've found or recent findings through human or automated or machine learning based scanning. Once you've identified that your developers are pushing out credentials and leaving you exposed, how do you address that? How do you fix it? We're going to talk about one solution, which is the HashiCorp Vault secrets management platform. It's free, open source. You can also use the cloud-based service and get more advanced features as well. So let's demonstrate. Let me show you what secrets are and how you can go about fixing that issue. So as one example, if you all heard about the recent solar winds, the blame was put on credentials being posted and simple as well. So SolarWinds 1, 2, 3 burned a lot of people. So if you're familiar with the recent attacks, you can understand why. There's even more with pipeline or supply chain attacks, open source software. There's a lot of different components that come into this. So secrets is a big deal. Let's go through a quick demo and I'll show you how you address this. So what I have first is a scanning demo. And this is designed to fail. What I have is another pipeline on another project. I have my variables. So this is my secret scanning demo pipeline. I have my variables defined. And what I'm using here is a basic single stage job. I'm running secrets detection. There are variables that are used as input. And then I'm running another job called git leaks. So one stage, one job, and that job is basically called part of the secrets detection stage. And I'm using this image from GitHub that is designed to look for credentials in your Git repo or repository. I'm passing it some arguments, and I'm also doing historical scanning. So in my CI/CD pipeline, I have environment variables, which you'll see here in a second, where I'm using historic scan. So SAST, git leaks, historic scan. That allows me to look back in time and see if credentials have ever been posted. So if I go back to the editor and I look at my task, you can see that I have a single stage, single job. That job is running a Docker container and running these commands. So if I go to the pipeline and kick that pipeline off, I have one that we can go right into. We run that pipeline. It runs very quickly. It doesn't affect other applications. It's a separate job. This could be managed by your security team. You could pass variables in if you want to hit different environments or different repos. And that's going to connect, pull down the Docker container, and then run through a series of secret detection processes using either the custom rule set that I've created, or it's going to leverage the default. So I'll show you how I modified that as well. Since there we go. That was pretty quick. So if we go back to the pipeline and we look at the results, you can see that I've added some fake credentials to this pipeline, and I've already been busted as a developer. So here I have my OWASP node project. This goes all the way back to the beginning and says, we found some private keys. That's not good. Public keys are okay. Private keys are a terrible idea. This goes all the way back to the beginning of this project. And if we keep scrolling down, painful as it is, go to the bottom. This would have failed the build. And that's a quality gate. You're basically saying if credentials are in there, we do not want to go live with this deployment. So you can see private keys, who put them there, when they put them there. If I look inside of here, you can see that I actually staged a fake private key. I've even staged some other fake credentials. So in my repository, under my files, I'm testing the secret solution. So I created a fake API key, fake credentials, JSON web token, private key. I have a super secret password in there as well. So you get the general idea. What I've done is I've gone through and built the solution and tested that solution, which is what you want to do. I also went through the process of integrating a custom rule set. So this TOML file is used to identify additional credentials. And I built these regex rules, which I won't get into regex. It's a little too deep for some folks. If you want to talk about it later, we can. There's some really cool tools out there, like regex 101. I created one for a generic JSON web token, and I created another one for just the word password, because strangely enough, that does not get picked up. I might look for pass W. I may look for just any combination of strings, or even take it to another level with machine learning and named entity recognition so that I can label and tag code. All right, so that job ran and would have failed. And if we go back to that pipeline, you'll see that it fails all the time, but it doesn't affect the other builds. So this is the problem, right? We have secrets, which I'll show you really quickly again. You saw the fake JSON token, you saw my private key. These are identified as things that you do not want to use. And for the record, these are all bogus. They're not going to work if you're screenshotting it. We have HashiCorp Vault. I'm using it in the cloud, and my Vault actually is already set up, and I have credentials in there under the container demo secret. And in here, I have my API key stored, a JSON web token, my private key, and a password. I can look at them in full JSON, or I can just keep them protected. None of these are legitimate. If the developer wanted to check them in or check them out, they could manually come in here and take these credentials and copy them, create environment variables, whatever they're going to do. But the credentials are safely stored and can be rotated as necessary. So access to the vault can be controlled, even if the credentials are static, because, for example, an API key may not be under your control. It may be some third party that you're integrating with. Passwords, same deal. So all my credentials, all of my secrets, not just passwords, are stored here and accessible to the developers. So that's great. This is a point and click tool. This also has an incredible command line and API. What I'll show you now is how we can use the HashiCorp Vault. HCP is a Hitachi content platform. And we're going to run through another job. So this is a different pipeline, a different environment. So I have my HCP Vault demo. I created a stage or a job called read secrets. And this is just to demonstrate how your CI/CD pipeline can integrate with this Vault platform. So I pull down a Docker container from HashiCorp, which is Vault. This is the official container. I add some packages. In particular, I'm adding the JSON query tool. I echo out my Vault address and my namespace. Then I go through the process of logging in with a token, which I have stored. I go through the Vault KV, which is the key value Vault, and I'm pulling down that demo secret that I just showed you a second ago in the user interface. And then I also pull it down again in JSON format. Why is that important? Because if you saw the default response, it's going to be like a blob of text. And if I'm a developer and I just want to check out credentials, even if I'm a systems administrator and I'm checking out credentials to run an application, I want to be able to leverage the API or the command line to pull these credentials down. So I'm using the JSON query tool to take that raw JSON output and pull back the specific credentials that I'm looking for. So when I run this pipeline, it's going to connect up, bring down those credentials and present them as, in this case, shown text. You would hide these normally, but for demo purposes, I'm sure you want to see that. From a visualization perspective, it's very simple. I'm just going to show you how to get these credentials. So if I go to the pipeline, we can kick this off. You'll see that it's a live demo. I'm going to run this pipeline. While it's running, I'm just going to show you the results from a prior. Or we can just watch it. It's pretty quick. So what I'm doing here is I'm storing credentials in a protected vault, and I'm allowing developers to check them out at runtime, whether through the CI/CD pipeline or through some form of command line automation on an operating system. So I pulled back the password, very simple. I pulled back that private key, separated. And then I also pulled back my API key. So it's just a raw string. And then here's my JSON web token, which I showed you in the interface. The raw JSON is here. So if I didn't use the JSON query tool or the JQ tool, I would have to parse all of this in my code. So if you're going to present it to your developers, you can give them a simple template to pull this information back, or just let them use that tool. Most of them are pretty sophisticated. The raw output is even worse. I have a key and a value. So here's my key, value, key, value. That's useful and interesting, but not simple for your developers. You want to make it simple so that they don't take shortcuts. All right, while that's running, let's go take a look at our pipeline and see how far along we are there. So staging, testing, and production have all completed, which means that our application is deployed. And if we go back to all of the pipelines, we should have our security pipeline running as well. That's completed, and we'll come back and take a look at that. Let's talk more about what we're actually doing in here. So we talked about secrets, we talked about vaulting. When we added the SAST template, and that was the security folder for templates, sast.gitlab.ci.yaml, what that's doing is presenting me with a bunch of different opportunities for static application security testing. Because it identified that I'm running JavaScript and Node.js, it's going to use the ESLint SAST tool and the Node.js scan SAST tool. These are pretty common tools. Trevor's going to actually show you how you can validate if these tools are effective or useful when he goes through the OpenSSF demonstration. But you're going to get a lot of false positives. You're also going to get a lot of true positives, where you're going to find out that, hey, you know what, you did not follow the best practice, and you're introducing risk to the business. But the developer will know this very quickly, as opposed to waiting till after something's in production and you've already been owned to find out that even though you had that hard outer shell on your network perimeter security, that application opened the door for everyone. The Node.js scan is pretty simple as well. A little more advanced in my opinion, because you can control code pattern searches using semgrep. We're not going to get into semgrep. We could probably do a whole webinar on that as well. After we added the SAST template, we moved on to dependency and license scanning. So from a dependency and license scanning perspective, this is not as interesting on the licensing side, but it is important to understand if you're using code that you are not licensed for, you run the risk of getting sued or have some kind of compliance within your organization that says we don't want to just use anyone's license or anyone's code. Dependency scanning is a big deal. In this template, we're using the Gymnasium dependency scan as well as the retired JS dependency scan. Those were automatically detected by the template. And typically these focus on common vulnerabilities and common weaknesses. So this is one of my favorite parts of the demo. We're going to go through the wormhole and take a look at dependency mapping through a visualization from a visualization perspective. And this is really cool. What we have, and I did not create this, is this cellular looking object. And this is effectively PyPy, or the setup tools for Python. And it looks like a cell, and you can see how all of these things are connected. If I zoom in, and it may be a little slow or difficult to see if you're coming overseas or if you're in a low latency environment, so I'll pause this for a second. It's a beautiful image, but here at the root, you can see that this is all dependencies tied to the Python setup tools. So when you think about, primary and secondary dependencies in your application, if you're just writing in Python, this is how deep that dependency map goes. This is an incredible visualization. This could be my background on my screen. Beautiful. All right, rambling. Next, we added dynamic application security testing. This is through a security template. For this pipeline and the application node goat, we're using the GitLab CI/CD pipeline to launch a Docker container that will run the OWASP Z attack proxy in passive mode, not active mode or authenticated mode, which we could do. It just take an incredibly long time. That is an automated tool, and we'll talk about how that's working, as well as OWASP ZAP using further automation with Selenium. And Selenium is basically a web application testing tool that can be used for security dynamics as well. So that OWASP ZAP tool kicked off in the Docker containers doing a few things, right? It's connecting to an API. and it's registering its session. Then it's going through and registering a series of rules. There are far too many to squeeze into a slide. But what we have here is passive scanning rules, vulnerable JS libraries, application error disclosure, incomplete or no cache control, or weak HTTP headers, character mismatches. You get this, you get the general idea, or concept security rules. So these are all going to run in that background. And when we go back and look at the output from the pipeline that I kicked off, you understand what's going on. When we talk about container scanning, this is important. This is very important. A lot of people use Docker. They use different repositories to run containers. You need to scan those containers. And if you're building your own Docker images, best practice is pretty simple. Run Docker scan before you post it to Docker so that you don't create work and cost for everyone else. I highly recommend building and maintaining your own containers so that security is at the forefront. And last but not least, from a security perspective, use signatures to verify that container. One typo or typo squatting can cause a lot of problems. So set up Docker content trust so that you're using SHA and MD5 signatures to identify that that is in fact the correct container. Tracking your issues are pretty important in a workflow. So CI/CD issue tracking, or Jira, for example, which I can demonstrate. And then last but not least, remediating and reporting periodically. So if we talk about container scanning, in my particular case, or in my demo, I am using Snyk. And for Snyk, I have a couple of containers that I've scanned. You can take a look and see that there were vulnerabilities associated with that. Actually, this is my Docker Hub. In Docker Hub, I have my containers that I've scanned. I have 2 high vulnerabilities and 1 medium and 0 lows. So these particularly are blockers in a pipeline. If you have very high or problems with input validation or problems with improper handling of exceptions, you introduce a significant amount of code vulnerability. From here, the whole team can see those vulnerabilities and work them as issues. The information related to the actual vulnerability are clearly documented. They tell you all about the CVE, CWE, and when it was disclosed. And the important part, in my opinion, is whether or not a proof of concept exists. So you see there's a high severity score, and it's a relatively evolved vulnerability. So that's what dependency scanning and container scanning combined are addressing. Try and move quickly. So let's see the results from our security scan. Go back to our pipeline. This was our last pipeline build. We can clearly see that all of those stages were executed. Staging, I didn't run any active dynamic application security testing scanning, so I would typically run that here so I don't break anything. In the test environment, we ran through a linting process for static application security testing, dependency mapping, license scanning, Node.js scanning, retire JS because you're still using JavaScript, secrets detection, and we ran SemGret static application security testing. Then we deployed the test, and what that did was push that application out to Heroku and connect it to MongoDB. We built production, and then last we ran the dynamic application security testing. So if we take a look at the results, you can review the container scan and say, okay, let's look at all these artifacts. Or if you're using the GitLab CI/CD pipeline, you have a pretty sophisticated vulnerability report. And this is with GitLab Ultimate. I'm not a sales guy. I'm just letting you know this is what we're demonstrating. Last webinar, we did Jenkins. We can do any pipeline that we need to. We stay pretty agnostic. But I'm not going to discredit vulnerability tools if they work. So this report is excellent for communicating with management or developing your backlog and figuring out which ones to address first. So we had a series of scanners run. We had a dynamic application security testing. We'll start from the end and work our way back. We found there are quite a few findings there. And as we drag all the way down, we'll see all of those findings. If we were to click on one of them, let's see here. It'll give you a lot of links on content security policy and how you can go about correcting those issues. Lots of examples where in particular it was executed. You have the common weakness, CSP policies, and then naturally a solution. And then from here, you can create an issue. In this particular job, I'm creating the issues in GitLab. However, if I wanted to, I could create an issue in Jira directly. So if I were to click on any one of these issues, this is just a slightly different project, but I have Jira integrated. I could create an issue here. It'll create it immediately in Jira for me. And then I can also, from that pipeline, see that data. So we know it's a bug. We can call whatever issue type we want. But that's going directly to Jira from the CI/CD pipeline. So if I were to go and look in the CI/CD pipeline, I can also see my Jira issues tracked right here. So it gives you that fully integrated experience, removes any doubt and issues associated with delays, right? They don't need to log into 5 different applications. They can do it all from one pipeline. Let's go back to the results on this one. This is test, right? Yes. I'm not going to spend too much time here, but just give you a general idea of all the scanners that we run. So that was dynamic application security testing. We have dependency scanning. This will identify any dependencies that are associated with my app. Since I'm using Node.js, you can rest assured my dependency map looks a lot like this. So we see that there's prototype pollution attacks, uncontrolled resource consumption. There's a lot of different issues here, mainly because this application is designed to be vulnerable for testing and learning and demonstration. So a lot of different dependencies. You can click on the dependency description. You can create an issue. It'll tell you who reported it, and you can go and create an issue and work to resolve that and prioritize it. We keep going through and look at different scans that occurred. We saw secret detection. Secrets may be a simple fix, but it tells you, how it was identified, CVE, and whether or not. Oh, actually, I still have DAST in there for dependency scanning. It tells me, that there's a secret key in here, or there's actually a password directly in the code. So if I go to the file and I want to look at it, I go, well, that's not actually a password, and say, ignore this one. But if I go back to the report and where it said there's a private key, I click and I take a look at that file. That is definitely a private key. So I would want to open an issue and have that removed immediately so that we don't go live with it. So you have some false positives, you have some true positives. Going back in the report, we'll take a look at one more scanner. And we'll look at SAST. So here we know that we're using the eval argument. This is a critical flaw because it allows code to be injected by the user because we're not controlling or protecting it effectively. It tells you how it was identified, so ESLint. It also tells you a link to the common weakness, and from there you can create issues and address them. But you'll notice here that you can dismiss, confirm, or resolve. So just integrating security is pretty simple. If we go back to the pipeline and take a look, that was the results, right? So if we look at the vulnerability report and we go back to the dynamic application security testing, I'll just show you what occurred in that container here in a second, but we went through all of these different processes and go back to the pipeline. Apologize for the mouse movement if I'm making anyone nauseous. DAST was our last stage. And when I click on that, I can see the output. All of this output was put into the vulnerability report. If I go back to the top, you can see I checked out my container, but I'm also using signatures from a trusted registry. So I know exactly which image I'm running. That way I'm not being infiltrated. And then I'm going through and connecting up to the container, connecting to the API, and running through all my different rules. You see the passive scan rules, vulnerable JS library, all the things that I showed you before, content security policies, things like that. And as it just runs through and passively scans, it's gonna capture issues and add them to the vulnerability report. One thing to keep in mind is if this fails, it will never make it to the vulnerability report. So you may have to look for artifacts here. That's pretty much all the demos that I have. What I'm going to do now is just give you a reference, something I've found very, very interesting. Some of the work that the Air Force has done, Platform One, there's a bunch of different terms out there and a ton of design reference. So there's some great documents on DevSecOps and developing a mature pipeline as well as tooling. You can see from the graphic here, there's a lot more going on than what was going on in my demo. But in order to build a platform like that, you're gonna have to put a little more time into it than I did. So with that, we'll talk last about when to track a ticket, right? Security will hit you with a ton of vulnerabilities. They'll hit you with a lot of false positives. Somebody's got to go find those, right? So there's a ton of findings, a lot of false positives, there's a slow review process and risk management. Then you have tracking and integration. And last but not least, prioritize. Which ones are we going to fix? So I showed you the Jira integration. That's easy for tracking bugs. But when do you go and say, look, this build cannot move forward because it will introduce bigger risk? Now, keep in mind, if you add security after you've already had a long-term pipeline going from your agile team, it's very possible they just shipped it with bad code already. When you see things that have a very high score, this is my sneak report for dependencies, and you can see that in one of my projects, I had this gitman arbitrary argument injection. It's got a high, it's got a CWE, CVE, CVSS score, all of which are high. But what's important, and when do you open an issue and start tracking it and actively working to resolve it, is when you see a mature exploit. That means there's freely available code or a proof of concept out there that anyone could run. Even someone who's not a sophisticated nation state attacker, anybody could own you at any time. So if you want data to leak, keep pushing code like this. If you want to be proactive, this is when you start to put a stop to the development process and say, we need to fix this fast. I'm going to turn it over to Trevor. So we have a bonus presentation, and this is really to review what we learned at Black Hat Europe 2020. It was all virtual, awesome event. There were many, many things presented, but this one is relevant to this webinar. And what we're going to talk about is testing and validating your tools. And how do you reduce the number of false positives? There are paid for tools, SAST tools, on-prem, Docker containers, all kinds of tools that are out there that will tell you your code is good or bad. But how do you know which ones are lying to you or which ones are creating work for your team? That was the purpose of the OpenSSF, is to evaluate these tools. So I'll turn it over to Trevor. Trevor will give you a breakdown as well as a demonstration. This is really cool stuff, so hopefully you're still awake. Turn it over to you, Trevor.
All right, thanks, Anthony. Nice work on the demos. Good afternoon, everyone, and thanks for joining us today. I'm going to talk about OpenSSF CVE Benchmark. It's an open source project that I learned about at Black Hat Europe in December. This project is relatively new, but as Anthony mentioned, has the potential to help select the most effective SAST tool for your environment. I was taking a DevSecOps course, and over the span of a few days, I had the chance to leverage many different tools to secure my CI/CD pipeline. But as we all know, security tools can be noisy with false positives, fail to detect false negatives, and all have a learning curve associated with them. So how do you evaluate the different security tools on the market? Once the Black Hat presentations kicked off, I watched Baz Van Schaik and Kevin Backhouse provide a new answer for that very question when they unveiled the CVE Benchmark, which is a tool for benchmarking, analyzing, and providing insight to the capabilities of popular SaaS tools. Both of these speakers work for GitHub, which is part of the Open Source Security Foundation. If you haven't heard of it, it's a collaborative group aimed at improving the security of open source software, consisting of members from different major tech companies. They demoed the CVE Benchmark, and I'd like to share some of the highlights of their presentation and get into a brief demo. All right, so who am I? As Anthony mentioned, my name is Trevor Prokop. I'm an IT consultant, director of professional services, and architect here at Critical Design. I have experience in IT operations, app delivery, and virtualization. I also have experience with application security and programming languages dating back to BASIC and Pascal through Golang. So let's get into the slides. So how do you test your tools? Let's first talk terminology. What is a false positive or a false negative? If we were talking about antivirus, false positive would be detecting a valid file as malicious, whereas a false negative would be allowing the malicious file to execute. Both situations aren't ideal and cause different headaches for many teams. In SAST, a false positive would be detecting a vulnerability when none exist, which really just creates noise. A false negative would mean that a vulnerability would simply go undetected. So you can see how these two important factors are. Both would cause extra work and lower your developer's confidence in your tool selection and could put your organization at risk. If you're evaluating a SAST tool, you definitely want to make sure that the detection is effective. And the goal in selecting the tools is to have a low false positive and false negative rate. So you might start with testing using a synthetic test suite such as SAM8 or intentionally vulnerable web apps such as OWASP Juice Shop or OWASP Node Goat, as Anthony had mentioned earlier. OWASP Juice Shop is a very polished web app for training pen testers with modern code. There's a few problems with this. It's not really designed to be a test suite, but it could be leveraged as one since the vulnerabilities are pretty well documented. The problem with Planet vulnerabilities is that they're somewhat obvious, so it's not exactly a mirror image of your code. And also, most of these are based off all-in-one code bases, so there's very few dependencies. And you saw the dependency graph that Anthony had shown. So synthetic test suites generate more false positives, and false positives become too noisy and often get ignored by developers. Since fixes aren't included, there's no good way to determine if a false positive exists without manually reviewing the code. But what's the alternative? What if we could use real-world code instead of test suites? Boy, there we go. So what are the benefits of testing security applications against real-world code? Well, for start, there's plenty of real-world examples. Take a look at the chart, and you'll see the vulnerabilities report per year. You'll notice that we've seen quite an uptick in CVEs starting around 2017. That's mostly attributed to the ease of creating a CVE, bug bounty programs, more security research exists, and overall higher focus on security. In 2021 alone, we've already seen over 6,000 new CVEs. That's almost 50 a day. So we know that the vulnerabilities exist, and we just need to find a way to leverage them in our testing. Open source software and GitHub brought a way for researchers to view source code and specifically see a bug fix outlined in the commits provided by the developer. Real-world code with GitHub metadata gives access to unpatched and patched code and allows us to see if false positives are still being flagged against code that's been patched. So what is the OpenSSF CVE benchmark? Well, it is a data set that contains over 200 CVEs and the specific repos associated with them for JavaScript and TypeScript. There's integration right now for ESLint, Node.js scan, and CodeQL. And then the way the testing framework works is that for each CVE, it's going to test the vulnerable and the patched code. For each CVE, we're going to look at the metadata, including the fix commit and the exact vulnerability location. And then the CVE benchmark tooling feeds those CVEs to the security tools and generates benchmark reports. So what are we looking for? We want to look at the number of vulnerabilities successfully detected. We want a low false negative rate. Then we're going to look at the number of patches successfully recognized, which equates to a low false positive rate. So what are we really looking for is how good are these tools at detecting vulnerable code, and how good are these tools at detecting patches? So let's take a look at the overview here. So how does CVE benchmark work? Well, CVE benchmark will reference the GitHub metadata for the CVE in the benchmark data set. Then it's going to feed that vulnerable and patched code bases into each tool. It'll scan the code bases. And when the CVE benchmark scans the vulnerable code base, it'll look to see if the tool flagged any code locations from metadata. If so, which rule? If not, it's a false negative since the vulnerability wasn't detected. Then it'll scan the patched code base. And does the rule have at least one fewer alerts for a particular type? If so, the tool must have detected the patch. And if it didn't, then it's a false positive because it still thinks the code is vulnerable. Then it adds both of the patched and unpatched results to the scorecard. So if you wanted to try this out for yourself, you can use a Linux VM. Mac and Windows is supported. What you would do is you'd clone their GitHub repo. You'd follow the setup instructions, which really include using npm to set up the tooling, installing drivers for whatever tool you want to test out of those three. Then you can configure the analysis tool driver. And then you just run the security tools against the benchmark. You can see in this example here, we're running the tool against ESLint, Node.js, and CodeQL. And then at the very end, we wildcard it with an asterisk, which just means all CVEs out of the 200 plus. Once you're done, you generate the report. And there's two options. You can look at text-based or JSON files, or actually load up a web server to be able to present the information. Here, the command would run a web server with ESLint, Node.js, and CodeQL against all CVEs. So let's get into a demo and see the results. All right, full screen. Hopefully you still see that. So I'm on the Ubuntu workstation here. It's in my virtual environment. You can see I'm running the command to run the tool. In this scenario, we're going to run the ESLint and CodeQL. And then instead of running against all CVEs, we're really going to target the MITRE top CWE 25 from the year 2020. So we would run that command. And once it finishes, so it would go out, it would grab all the GitHub repos, and it would do the scanning of the patched and the unpatched code and generate those results. Once that's finished, we'd run a command similar to this one here, where we just input the server, the tools that we're running against, and what results we want to actually specifically look at. When you run that, then you get the web server built-in loads up, and you can get out to the report. So what we're looking at here, you see the two columns, that's CodeQL and ESLint. If you were doing Node.js scan, you'd have a third column. But at the very top, you see a summary. Then underneath there, we have the CWEs and then the CVEs that are associated with it. And you can see individual scoring. What we see here is the green indicates that a vulnerability and patch were both detected. So that's great. There's no false positives, no false negatives. The orange that we would see here or up top would indicate that the patched code was detected as vulnerable, but then that would result in a false positive on the patched code because it didn't detect the patch was in the location. And then the red would mean that the tool didn't detect the vulnerability at all, which would be a false negative since we know the code's vulnerable. If none of the tools, so in this case CodeQL and ESLint detected, they didn't detect the vulnerability, it would just simply be omitted from their results. So let's take a look here. We'll take a demo sample where we have CodeQL detecting the vulnerability and the patch where ESLint did not. So this scenario right here, there's no green under the ESLint. So we'll take a look here at the one that ends in 427. I'm just going to right click here so we can open up in a new tab. And we go right to the line where the vulnerability exists. So this is really nice. And it shows you that there's an incomplete URL scheme check. So if we scroll up in the report, we can see that CodeQL detected the vulnerability, detected the patch, and ESLint did not. So we can individually go through the different results. We could come back over to the benchmark data. This shows you specifically that CVE was identified, what Git repo, what location, line 878, and the explanation. And then we can take a look here at the actual patched code. So if we open this up in a new tab, we can see that this GitHub comment is link fixed to prevent cross-site scripting. We see the previous line, and then we see the remediate line. So that's an example there where we were able to see that CodeQL picked up a vulnerability and a patch, and ESLint did not. Let's take a look at another example here where both tools found the vulnerability and the patch. So we just kind of scroll down here until we find some green. There's green on both sides. Find the first area where we have 2 green check boxes. That's the 16460. We'll open that up in a new tab. So again, takes you directly to the line. You can see the square and the triangle. They represent each of the respective tools. We can see that there's unsafe shell command constructed from the library input. And we can scroll up. We see the chart again here. We see that CodeQL and ESLint both detected the patch and the vulnerability. And then if we wanted to find out some more information, we can look at the benchmark data. And if we open up the patched, just open this up in a new tab, we notice here this is version 1.0. It's Umbra Engineering. You can see in the comments here, fixes a potential command injection issue. So this is the data that the tool's based on, right? We have this real world data. If we were interested in learning more about it, besides looking at the exact lines where the vulnerability existed, we can actually click right here for the NIST National Vulnerability Database. We can open that up in a new tab. And we take a look here. We see the CVE. We can see the CVE score, 8.9. If we scroll down a little bit more, we see some of the CWEs, but known affected software, Umbra Engineering, up to version 1. So that's you'll be able to dig in more information off that last tab. But as you can see, the CVE Benchmark project can really shed light into the effectiveness of a SAST tool when we have patched and unpatched code. The results are pretty valuable and definitely interesting. I urge you to take a deep dive yourself if you want to learn more. Let's go back to the slides here and finish up. So while I was testing the CVE benchmark, what I did learn is that if you're going to test this out in a virtual environment, make sure you give yourself enough disk space. I underestimated how large these Git repos would be when I downloaded all the source code. And then, don't expect instant results. It takes time to scan real code. For me to scan against all 200 plus CVEs with all 3 tools, it took a whole weekend. So you can, if you wanted to skinny that down and not scan all CVEs, you can use examples like this where you pick a specific year, a specific CWE, or as I demonstrated, the CWE top 25 from 2020. So the framework's still young, but has a lot of potential. I'm looking forward to seeing how it matures and can be leveraged in the future as additional CVEs are added to the data set. But if you're interested in contributing, OpenSSF is looking for help expanding on their data set and improving the tooling. You can develop a tool integration with less than 200 lines of code. All right, and I will send it back to Anthony. Thank you.
Yeah, great demo, Trevor. Nice work.
Thanks.
All right. Well, let's wrap this up. I have just a few words and then we'll hand it back off to Jen. So in summary, what are we talking about here? We're talking about shifting security to the left. We're showing you that it's relatively simple. Even if you just do a first pass and use the default tools or templates that are available, you're still better off than you are not having security integrated into your environment. But what it also does is it reduces cost, it reduces time. It reduces rework efforts. If you spend months developing a feature and then all of a sudden you find out you have a gaping security hole right as soon as you're ready to deploy or right after you deploy, that's a problem for everybody, including the business as well as developers, security, and risk management. By integrating the pipeline, it also allows you to maintain agility. So you can still move fast, but you're moving fast with high quality and high security. I'll turn it over to Jen.
Okay, give me one moment, guys. Okay, yes. All right, there we go. Okay, cool. So thanks, Anthony and Trevor, for putting all that cool stuff together. Just really quick, I want to discuss the different ways we can help you achieve your goals around DevOps, DevSecOps, integration and support, or even MLOps. Here at CDA, we offer staff augmentation-based services where we provide a skilled resource to help fill any gaps in your organization, project-based services to help you achieve your goals or challenges on time and on budget, and we also have managed services where we help offload some routine operations on an ongoing basis. Okay, now why CDA? Why the heck not? We have 20 plus years of experience. We offer the flexibility to accommodate your availability. We are accountable and 100% committed to your business needs. So in other words, we get it done because your success is our success, and we are pretty awesome at what we do here.